Okay, so let's start our unit 4. So the unit 4, we are starting from OpenCV part. So I guess most of the part is covered in lab, but let us again discuss in brief detail. So what OpenCV is? OpenCV, basically you may have used this library, and it stands for Open Source Computer Vision Library, and I have included some basic details about this. You can read it as per your convenience. And so basically it is used for image and video manipulation, and you can read, write, manipulate the image or video content. You can detect feature, and you can also extract features, object detection and tracking, image segmentation, and we have also discussed the image segmentation part of the OpenCV library in this lecture only, and machine learning integration, camera calibration, and 3D reconstruction that we already discussed, but we have not applied this in Python. Anyway, we are not going to discuss that in that much detail, but let us discuss this. GUI and visualization. And initially, see, the OpenCV is written in C++, while you can see the support, the interface is for most of the available languages, for example, Python, Java, MATLAB. But you can see mostly people in science and engineering uses Python and MATLAB majorly for computer vision. Okay, so, and you can read these two slides for even more details. And now first topic is OpenCVStandard images and datasets. I have included this link. You can open it, and upon opening it you can see all these are different data sets, okay, that only OpenCV has to offer. Okay, now there are many. I will suggest you to at least explore any 5. Okay, for example, if you open action recognition, you can see how you can use this. You can just directly use this to import the whole data set, and let's see what's there in this data set. So a large human database, for example, for the introduction. So these are the images. Human motion database. These are the images. For example, you can see brushing hair, cartwheel, catch, right? Eat, fall, fencing, kick, jump, hug, hit. So all these are different human actions that can be used in computer vision and all. So you can see face recognition, gesture recognition, human pose. We already have discussed about this. Image registration we have discussed. Image segmentation we have discussed. Multi-view stereo matching we have discussed. So we have discussed many of these, and you just need to apply all that. For example, you can also see this human image dataset. Okay, this is not working. What else? Face recognition. Let's explore this. So I would suggest you to just explore these datasets and about the description of these datasets. So, for example, unfiltered face for gender and age classification. Okay, so the face, this face recognition is for gender and age classification, and in the cameras you might have seen that age is also written in many mobile phones. Okay, so you can see. So you can also implement a minor project using these datasets provided by OpenCV directly. Now next is Python for computer vision. So as I already discussed in the theory class as well, that you already said that you know the basic operations about image loading and applying basic filters. Let us again discuss that in a brief detail. So for example, for computer vision, the requirement of Python is very basic. So for example, the for loops and all these are very what do I say? Very rarely used. You can directly apply like this. For example, we have discussed about the different segmentations, Otsu, region growing, and all those. So you can see the code is very straightforward. First of all, you have to import library, And CV is not imported, you can import it on your own, and you just have to give input an image, convert it to the grayscale, and just apply the function, the OTSU function, and give the thresholds, and it will give you the output, as simple as that. Now I have applied the OTSU in a simple cat image. So these two images I have downloaded from the internet. So another thing is, as I don't know about the breed of these cats, I just searched about cat images, and these images shows up. So I applied OTSU, and you can see the output over here. So output is a very good, may not be the perfect, but the output is good. So you can, and also in the this image, if you apply the OTSU, this will be your output. Now what if you apply the OTSU once again, I mean 2 times. For example, this is your input and this is your output. Now if you're using this image as an input, so agar aap dobara OTSU apply karenge, this will be your output. Okay, so you can apply any number of times, but you know that the segmentation the mask is better over here. Okay, so likewise, as I already discussed about the transfer learning, if you remember, in the transfer learning, we discussed about the ResNet, ResNet and AlexNet, all these. So just for the knowledge, I'm showing you this output that I tried. So you can see, basically we are applying ResNet. What is ResNet? This is a transfer learning based convolution neural network, which is already pre-trained based on Google ImageNet dataset. We already have discussed about this. So I have applied this. This is the image. You can see this image that I have downloaded from internet. As I don't know what is the breed of this cat, so I'll input this image in the ResNet, and it's supposed to give me the output. Yes, so this is the output, and my ResNet model is 53% sure that this is Tabby. So let's see what Tabby is. Okay, pretty much it. This is Tabby. The breed is exactly what we have inputted over here. Okay, so you can also see I'm using Google Colab, but you can use Jupyter Notebook. You can use Jupyter Notebook along with Anaconda. So you can, and in this way, you can run it directly in your system. And Google, what's better with Google Colab is, if you don't have good RAM, good storage, it will do most of the job on its own. But again, this is for a very light a light program, a light model. Okay, so let us okay. So now next is, as we are discussing Python for CV. So this is the image of a tomato leaf which is diseased, okay, affected by a disease called late blight. Now I have applied all the segmentation that we have discussed in Python. So global thresholding, we know that we set one simple threshold, and we already have discussed about this, right? Adaptive, there will be a window. OTSU, you know, histogram of intensities. Region growing, there will be seed. Active contours, there will be contour. See, this is the output of active contours. Okay, so that's why you are not seeing the contours over here. Now there is also gradient edge detection, Laplacian, Kenny edge detection. So all these are different types of algorithms that you can apply over here, and you don't have to be very highly skilled for this. You just need to change a few lines of this code, and you can easily run all these algorithms. Next is Python for image processing. Now image processing, we already have discussed, for example, rotation, scaling, and so we already have discussed of all these. Now okay, so this is Jupyter that we tried to open earlier, and you can also create new projects over here, and you can also open whatever you have downloaded. So for example, all the see, this is, you can see that this is a bit slower if we compare it with Google Colab. So that's why I use Google Colab. And you can see these are all different files, and you can also open it over here. Okay, so this is your the same code that we have implemented on Colab. So you can use it in either way. So let's come back to image processing. Image processing, we already have discussed rotation, scaling, affine transformation, all these rotations and transformation. So this is Python imaging library that you can also use. Okay, so there are a handful of libraries like OpenCV, Matplot, PIL, and a few more. You can make use of these. And first of all, what we have done is we opened our image and saved in image, saved in this variable. Okay, so now we are rotating this image by 90 degrees. So this is our input image. Okay, so what we are doing is rotating it by 90 degrees. So upon rotating, this will be your output. So now if we have rotated this image to 180 degree, this would have been our output, right? So likewise, you can also, so this is a very simple code, and if you want to do some basic transformation, the code will be very simple. Further, you can also apply the scaling. So what we have done here is, this is the same, the first two lines are same. Then in the resized image variable, we have stored this output. What we are doing is, see, take some time and just think about it. We have divided the width with 2. That means width is half. We divided the width in divided by the width is divided by 2. So now the width will be half. Now the height is as it is. Okay, so height will be same. So now output will be something like this. So you can see the width is divided by 2, but height is again same. So again, scaling can be done in this way, and there are many options. For example, we have discussed the affine transformations, right? So you can change all these values and the output will be changed accordingly. Another thing we talk about in the image enhancement is contrast stretching. So basically what happens is, for example, if I have one image, so if we draw the contrast of this image, the plot will be something like this. Okay, so now we all know, see, for example, if the image is of for example, if the image is of 255 by 255 pixels, for example, this is your length and this is your height, sorry, whatever, this is your length and this is your breadth. Okay, height and this should be your height and width. Okay, so this should be your height and width. So your image is squared over here, right? So now what we can do is, we can see the intensity. 0 means the value is very dark, and 255 means the value is very bright. So upon seeing this this plot, you can say that the image is very bright, right? Now, but in contrast stretching, so for example, if we have this image, so how many pixels there would be? For example, if we have these images, so there will be total of 65,000 pixels that will be used in a grayscale image. But on the other hand, if this would be an RGB image, then again this would be multiplied by 3. Okay, so But here we are discussing about the the grayscale image. So we can say that there are almost 65,000 pixels that we are supposed to consider. But here, so you can see that out of them, 30,000, these are the frequency. For example, the pixels having 200 intensity is around 30,000. Okay, so likewise. So now you can see the plot is not very stretched. Okay, it is very shrinked. So what we do in contrast stretching is we stretch the plot. So you can see the distribution is the intensities, the pixels are distributed over 0 to 255 instead of only this part. So what it does is, for example, you can see the output over here. So this is your input and this is your contrast of this input. While after applying the contrast stretching, the plot would be something like this and the output would be something like this. So you can see by just looking at it, you can see the difference in these two images. Okay, so this is your contrast stretching and this is used in image enhancement. And if you want the code, it is a bit complex, but you can see. So this not a very complex one. The main thing is this equation. So we have applied the same contrast stretching, which you can see over here. We have applied this contrast stretching and the output can be seen over here. So we have not applied the contrast stretching. So basically this is your input image and this is what it would look like if we convert it to the grayscale. Now we are plotting its contrast. So the contrast histogram looks something like this. So again, this is not a very stretched, this is not a very stringed. You can see the values are very small, but again, this is not a very shrinked histogram. So we have applied it, but the output looks almost the same. So that's why I have not included the output over here.